Hello. Hello and welcome to this video. So in this video, we will go through two things. One is the clone trait and other is inheritance through super traits. So first we will look at the clone trait. Now clone trait is provided by the Rust runtime or the language itself. So for example, what you have to do is you have to do this derive block and then you can put clone inside. So if you do that, a clone implementation will be provided for your object. And here also clone is derived from the runtime. Now debug is derived so that we can print the structures, and copy here is derived for copying. Now the first question is, why should we use clone trait? So what happens is that, at least for the beginners, it is very useful, because if you don't know how to maintain lifetimes and borrowing of values, then you simply perform a clone. So that alleviates the learning curve a bit. As you learn more and more and get comfortable with the lifetime and the borrow checker, you get rid of those clone calls. Second is, what does clone does? So it creates an exact copy of the object on which it is invoked. So we'll see that in a bit. So we have a structure unit, which is an empty struct, and we have a structure pair, which consists of two box elements, and that box puts a 32-bit signed integer. That means the integers will be placed on heap, and pair will be two pairs. You can take any other structure as well, it works. Okay. Now we create a variable unit of type unit, and then we create copied unit, which is copied from unit. Now observe that the structure unit is empty, so there is nothing to move here. Usually Rust will move the value. So you can print original and copy, and you can print original and copy. Not, it will print unit for both the cases, original unit and copy unit. Now we create a pair object. So we put 1 and 2 in that, and we print the first and second items of the tuple pair. Now we move this pair. Okay. So how do we move? We create another value, or rather another variable, moved pair, and we assign pair to it. So it will be moved, and then we can print moved pair. Now at this moment, if you try to print this, you'll straight up get an error. Borrow of moved value pair. Okay, Rust will immediately tell you that it is moved. So now what we do is we clone this, and then we drop moved pair. So for now, I will not drop it. Okay. So this is what I will print. So you see, you cloned, then even after cloning, you can print the moved pair. Okay. So that means the data was not moved, and we can still access the moved pair. So instead of a simple assignment, we invoke the method clone on this. And of course, we can print the clone pair. So I'll run this program, and we will see how this behaves. I'll go run. So it prints unit for first two, and then it prints 1 and 2. Then it prints the moved pair. Then it prints the original pair, and finally the clone pair. Okay. Now, if you drop this moved pair, then you will immediately get an error here that we are using the moved pair. So we are trying to borrow it, so it won't work. So that was all about clone. It is very simple to use. So whenever, if you are new and you are learning Rust, you can make use of clone, but It is not good for efficiency. Certain times you will be required to implement clone or rather use clone depending on the library which you are using. Some libraries have some types which require cloning and all that. But in general, those cases are very rare. So typically you should avoid clone because it is a very expensive operation. Okay. Particularly for larger objects, it is efficient. It is not efficient. It will consume more memory, more CPU, and you will have two copies of the same object for nothing. Now we come to something called supertraits in Rust. So as you know, Rust does not have all the bells and whistles of object-oriented programming languages. But if you remember our discussion on impulse rate, where we could pass impulse as an argument or we could return an impulse rate. So if you have not watched that video, I would suggest that you go and watch the video on impulse rate. So what we do here is we have a trait animal. It has two methods, name and sound. So they return a string slice. And then we have describe, which returns a string. And it says, it takes the name says sound. Then we have another trait swimmer, which has one method, sim speed, which returns a 32-bit float. And we have a swimming style, which returns a string, which tells us that this particular swimmer swims at what speed. Then we have hunter, which has a prey number, which returns a string slice. And we have hunt, which returns a string. And it tells that it hunts what. Now we have a super trait. It is called super trait. It's not something like a hard-coded word. It is popular in Rust terminology. You won't find this in other languages in general. So we create this trait which requires animal, swimmer, and hunter all to be implemented. And it has a profile method which returns a string. So what this does is it describes the animal, it calls the swimming style, and it calls the hunt. So describe, swimming style, and hunt from these three traits are called. It can call those because it is composed of those traits. So that is one thing. That is the aquatic predator trait. Now we implement some objects. So you have a shark object, not really object, struct here, which has one parameter named string. And then we implement animal trait for shark. So the name returns the name as string slice, and then sound returns silent. Then we need to implement swimmer trait, and it returns 56.0. And prey trait is returns fish here for the shark. And finally, we call impulse aquatic predator for shark. So the profile function will be available for shark. The reason why we can call profile is because these are now available for shark. When you implement animal trait, that is, you implement name and sound, it gives you describe from here. When you implement the swimmer, swim speed, that is this trait, you get swimming style. And when you implement the prey, you get hunt. And these three functions, when used inside aquatic predator, it satisfies the condition for shark to invoke aquatic predator trait. Now we have another animal crocodile, which has name as the name, and we have sound as his. Swimming speed is 15, and swimming style is lurks and ambushes at swim speed kilometer per hour. And we have hunter. So prey method from hunter trait, and it hunts animals. And aquatic predator is also applicable for crocodile. Now we'll there is another method, print predator info. So you see, this is the static dispatch. It takes a reference of aquatic predator trait, and it calls name, sound, swim speed, prey, and profile on those aquatic predator objects or other traits. So objects will invoke the trait, and then this will be printed. Now you see, we create shark with the name great white and crocodile with Nile croc, and we do the static dispatch by calling print predator info. Now, if you remember our infiltrate discussion, we can also invoke the dynamic dispatch. So we have created a vector. So vector require the dynamic aquatic predator requires to be boxed, that is placed on heap. So we have box for that, and we have two objects, one for shark, another for crocodile. Both are wrapped inside box view, that is, they are placed on heap, and then we iterate on the elements of this vector. Okay, that is, we iterate on predators, and we get the box dynamic aquatic predator, and we invoke profile of that. So that would be an example of dynamic dispatch. And as we have discussed, the static dispatch is compile time, so it is faster, and there are certain checks which can be performed. And dynamic dispatch is more versatile, but it is slower, and it relies on the runtime invocations. So we will go and see the Supertraits. We do cargo run, and it prints what we expect. So these two come from print predator info, and these two come from the profile function. Okay. So the essence is that you can create a trait by composing several other traits. Okay. So aquatic predator, for example, is composed of animal, swimmer, and hunter. Okay. So the functionality which is implemented in animal, swimmer, and hunter trait are not duplicated in the implementation of aquatic predator, but we can still call those. So that's how it implements the inheritance type of functionality, and we do not need to duplicate the implementation of the traits of which the super trait is composed of. So I believe, I think I have covered this in detail, and it should be simple. Again, if you have not understood any part of this, then you need to go back to the infiltrate video. I'll show you, for example, let me revisit that example for you. So infiltrate, if you see, so I am referring to this video. There was another one, I believe, which was on dynamic trait. So you need to go to that video that has more information than this. So if you see that, there are other videos also. So let me try to find out more. DIN trait, I believe, was the name. Yeah, DIN 1. So DIN 1 and DIN 2 you need to see as well. So these were explained in the infiltrate example. So, and then there was DIN 2. So if you look at DIN trait, DIN example, you see it takes a DIN animal. So this was the example of dynamic dispatch. And then we had a DIN 2, which was, I believe, another example of dynamic traits. So you see, we have a shape area, and we have a circle, we have a square, and circle and square implement the area for shape. And then we have print area, which takes a dynamic shape, and we send it circle and square. So this was the example of dynamic dispatch. So with this, I will end this video here, and I hope that you're enjoying this series of videos on Rust. Let me know what you think in comments. If you have questions or suggestions, again, make use of the comment box. So thanks for watching the video, and I'll see you in the next one. Enjoy.